Hello everybody, today I am discussing the problems related to applications of integration which carries 5 marks in the final board exam, which is also very important and very easily you can solve these applications of integration problems. Okay, so if you like this channel, please subscribe my channel, share my channel. Let us move to the first question. Find the area enclosed by the circle x square plus y square is equals to a square. So see there they have given the equation of a circle. Okay. So in this equation, the center of the circle, this is not actually the center of the circle is origin. Okay. So in this case, because h and k both are they have not given means obviously it is 0 only. So that's why the center of the circle is existing in the origin. So let us move to the question. They have asked to find the area enclosed by the circle x square plus y square equal to a square. Let us consider one circle. I am considering one circle. Okay. So in this circle, they have asked to find the area of the circle. See, suddenly if they ask now what is the area of a circle, you know area of a circle. Area of a circle is pi r square, isn't it? So pi r square. R means what? Radius. Here in this equation, in the place of radius, we are having a. So what actually we should get? Using integration, we should find the area of the circle. So pi a square we must find out. So what I will do here, first consider the area enclosed. That means the area of the area enclosed in the first quadrant. If you multiply that area by 4, you will get the required area. That is what I will do here. Okay. So let us move to the solution of this question. Given the area of a circle, x square plus y square is equal to a square. So from this circle equation, I will find out the y value. Taking x square to right hand side, it becomes a square minus x square. Then y is equals to square root of a square minus x square. So this is what we will get. We got y value. Okay. So what we should do now, we should find the area. So required area is equals to 4 times integral. Observe this properly. This point is the origin, isn't it? 0, comma 0. They have given the radius. So from here to here, the distance is what they have given? A. It means if you take this point as A, the coordinates of A will be A, comma 0. Okay, so this point is 0, this point is what? A. So you are finding the area, this portion you are finding. Okay, so this is on the x-axis from 0 to A. So you here you must consider the lower limit as 0 and upper limit as A. 0 to A, y into dx. As you know y value already, we have got integral from 0 to A square root of A square minus x square into dx. You know the formula for root of A, integral of root of A square minus x square. Directly apply that formula 4 times that means x by 2. Directly I'm applying the formula. Okay, so x by 2 into root of a square minus x square plus just a second, a square minus x square plus a square by 2 into sine inverse of x by a. Limit is from 0 to a. So now see here, what I will do, I will apply the limits, upper limit as well as the lower limit. Always applying, first you must consider the upper limit. Wherever you are having x, apply the upper limit. A by 2 into root of a square minus a square plus a square by 2 into sine inverse of a by a. Wherever we are having x and substituting the a value. This is over, that is applying the upper limit is over. Put a minus symbol, apply the lower limit. See, I am taking the flare bracket in between this. So now I apply the lower limit. 0 by 2 into root of a square minus 0 plus a square by 2 into sine inverse of 0 by a. So now see here, very simple to simplify. This is a square minus a square, it will get cancelled. It becomes 0. 0 into anything is 0. So this term becomes what? 0. Okay. Next, come to this term. This is a gets cancelled. Only 1 will remain here. So here 0 into anything it is 0. So this term becomes 0. Even here sine inverse 0 means 0. 0 into anything is 0. This term is also 0. Okay. So now I will write down the remaining terms. 4 into a square by 2 into sine inverse 1. I think you know the formula for sine inverse 1. This is 2 ones are 2 twos are 2a square. Sine inverse 1 means it is pi by 2. So even this 2 gets cancelled. Final answer is pi a square. So this is what actually we should get the area of the required circle. So pi a square square units. See, this is actually 5 marks question. Finding right compulsory, you must write the figure. Okay, for figure 1 mark. Till here, if you, that means finding the y value 1 mark. For applying the formula 1 mark, that means y into dx, applying the y value. Okay, so then integrating 1 mark, and for the final answer 1 mark. This is how they divide the marks. So I think you have got this question. I will move to the next question. The second question is, find the area enclosed by the ellipse x square by a square plus y square by b square is equals to 1. See, the previous problem is finding the area enclosed by the circle. This is ellipse they have given. Okay. So this is also same as the previous problem, but a small changes in finding the value of y. Okay. So the formula what you are applying for the integration of the same formula even for this problem also we will apply. So you will get to know after doing this problem. Let me do this problem. I will move to the given problem. The solution. Let us see the solution of this question. I will consider the equation of the ellipse. So what they have given, x square by a square plus y square by b square is equals to 1. So from this equation, let us find out the value of y. So how to find out the y? Write this, take this x square by a square to right hand side. Then it becomes what? Y square by b square is equals to 1 minus x square by a square. See, we want only the y square value. So shift this denominator term to right hand side. Then it becomes, I will do here. So y square is equals to b square into. See, for these two terms, I will take the LCM. The LCM is a square. So it becomes a square minus x square. I will take a square outside. So then y square is equals to b square by a square into a square minus x square. So this is what actually the y square value. What we want actually y. So therefore y can be written as b square means b by a, it becomes square root of a square minus x square. Okay, by taking the root on both the side, left hand side y square we are having, square and root gets cancelled. In the right hand side, b square by a square is there, so b square and a square, the root along with the root it will get cancelled, only b by a will remain. Next, root of a square minus x square. Now let me find the required area. So the required area is, required area y is equals to, sorry, a is equals to 4 times, same as the circle. Okay, see, I am finding the area enclosed by the enclosed in the first quadrant. If you multiply by 4, you will get the entire area of the ellipse. So that's why 4 times integral. Even here also, see, on the x-axis the first point is 0 and the ending point is a. So limit is from 0 to a. The curve, this is what actually the curve. Okay, so the curve is ellipse equation. So integral from 0 to a, b by a, or else write down y into dx. So as you know y value, substitute over there. Integral from 0 to a, b by a into root of a square minus x square. Okay, so now see here b by a, it is a constant. I will take outside the integral 4b by a integral from 0 to a root of a square minus x square. So as you know the formula for root of a square minus x square, apply that formula. Let me apply what we will get 4 times or 4b by a into x by 2 into root of a square minus x square plus a square by 2 into sine inverse of x by a limit from 0 to a. See, this is same formula. Even for the area of finding the area of a circle, you will apply the same formula. Even finding the area of the ellipse also, we will apply the same formula. Now, I will substitute the upper limit as well as the lower limit. Okay. So, let me substitute. I will substitute the upper limit a wherever we are having x. So, in those place, it becomes a by 2 into root of a square minus a square plus a square by 2 into sine inverse of a by a. See, I applied the upper limit. Now put a negative symbol and apply the lower limit. The lower limit is 0 by 2 into root of a square minus 0 plus a square by 2 into sine inverse of 0. So whichever term will become 0, let us see first. A square minus a square means it is 0. So it becomes 0. A by a means it will get cancelled. You will get 1. Here, the 0 into anything is 0. This term becomes 0. Sine inverse 0 is 0. So the whole term becomes 0. I will write down the remaining terms. The remaining terms are 4b by a into a square by 2 sine inverse 1. Sine inverse 1 is pi by 2. Isn't it? So pi by 4 gets cancelled, 1a gets cancelled. The remaining is pi ab. Pi ab square units. So this is what actually the final answer. This is the area of the ellipse. This is how we find out the area of the ellipse using integration. Even for this question also, figure is very important. Compulsory you must write the figure. Okay, don't forget to write the figure. For writing the figure 1 mark, finding the y value as you know 1 mark, it carries 1 mark. Those 2 marks. Required area, writing the formula 1 mark, then integrating 1 mark, getting the final answer 1 mark. Totally it's a 5 marks question, compulsory question. Okay, I think you have got this question. I will move to the next. The question. Third question is, find the area of the region bounded by the ellipse x square by 16 plus y square by 9 is equals to 1. See, even this question is also same as the previous problem. In the previous problem, we had x square by a square plus y square by b square. In the place of a square in this question, we are having 16, isn't it? So, if a square is 16, then a becomes 4. B square, in the place of b square, we are having 9. So, b is equal to 3. Okay. So, this always represents the major axis, length of major axis, and this represents the length of minor axis. What is the question? They have asked to find the area of the region bounded by the ellipse. Okay. So same as the previous problem. Whatever the area we will get in the first quadrant, multiply by 4. If you multiply that by 4, you will get the required area. Okay. So let us do the problem. I will move to the solution. Let me write the given question. X square by 16 plus y square by 9 is equals to 1. Okay. So same as the previous problem. Let me find out the value of y here. Y square by 9. I will take this x square by 16 to right hand side. So y square, we don't want this 9 in the left hand side. That's why I will shift it to right hand side. It goes to the numerator of right hand side. So after taking the LCM for those two terms, 16 will be the LCM, 16 minus x square. So I will take 16 outside. It becomes 9 by 16 into 16 minus x square. This is what actually y square, isn't it? So we want y value. Then y is equals to, taking root on both the side, 3 by 4 into square root of 16 means it is 4 square minus x square. See, we have got the y value, then required area. I will apply the required area formula. That is, required area is equals to integral from 0 to, observe here what we are finding from here to here, isn't it? From here to here the length is what? Length of major axis, that is 4. From here to here the distance is 4. So, and the curve is this one, ellipse curve, isn't it? So this is what we are finding. The first point of the curve existing on 0 and the last point is at 4. So limit from 0 to 4 y into dx. So let me apply the value of y. Integral 0 to 4 y is, observe here, I am finding the area of the first quadrant. If you multiply by 4 you will get the required area. So that's why be careful, don't forget to write the 4 area. Required area is 4 times. Okay, so here I will write that required area A is equal to 4 times. Ah, apply the y value. Y is what? 9 by 16. Sorry, 3 by 4. Y is equals to 3 by 4 into root of 4 square minus x square with respect to x. So take 3 by 4, so, or else 4 gets cancelled here, only 3 will remain. Okay, so 3 into integral 0 to 4 root of 4 square minus x square with respect to x. Let me apply the formula for this 3 times. What is the formula? X by 2, isn't it? X by 2 into root of 16 minus x square plus 4 by 2. 4 by 2 means, sorry, a square by 2. A square by 2 means 16 by 2 into sine inverse of x by a. A means 4. Limit from 0 to 4. Now, let me apply the upper limit first and afterwards the lower limit. So now I'm applying the upper limit. 4 by 2 into square root of 16 minus 4 square. 4 square means even it is also 16 plus 16 by 2 into sine inverse of 4 by 4. So I applied the upper limit. Put a negative symbol, apply the lower limit. The lower limit is 0. Wherever you are having x, apply 0. So 0 by 2 into 6 root of 16 minus 0 plus 16 by 2 into sine inverse of 0 by 4. So as usual, as we have done in the previous problem, whichever term will get 0, let me find out. So the first term becomes 0 because 16 minus 16 is 0. 0 into anything is 0. So 4 it will get cancelled. Only 1 will remain. Here 0 into anything is 0. So that's why this becomes 0. Sine inverse 0 is 0. 0 into anything is 0. Only the second term will remain. So 2 ones are 2 eights after cancelling this. So 3 into 8 into sine inverse of 1. Sine inverse of 1 is pi by 2. Okay. So 2 ones are 2 fours are 4 threes are 12 pi. So this is what actually the required answer. The final answer is 12 pi square units. Okay. So see, actually area of the ellipse is what? Pi AB, isn't it? The area of the ellipse is pi AB. So A is equal to 3, B is equal to 4. What you should get? Pi into 3 into 4. It is 12 pi. This is what the verification you can do. After getting the final answer, whether the problem is correct or wrong, you can verify here. Okay. I think you have got this question. I will move to the next question. I move to the fourth question. Find the area of the region enclosed by the line y is equals to 3x plus 2. The x-axis and the ordinates x equal to minus 1 and x is equal to plus 1. See this, actually they have given just a line equation, isn't it? So finding the line equation, that means y is equal to 3x plus 2 they have given, and they have given the ordinates. So first let me find out. See, we don't know which area we should find out. So that's why let me find out where the point actually exists, the line and all. So x is equal to minus 1 they have given. So apply that in the given curve. Okay. At x equal to minus 1, y is equal to minus 3. That is 3 into minus 1 plus 2. 3 into minus 1 plus 2, it is minus 1. At x is equal to plus 1, y is equal to 3 into 1 plus 2, it is 5. Observe there what the points we have got: minus 1 comma minus 1 and 1 comma 5. So draw the figure. Let me draw the figure first. Taking the values 1, this is 2 on the x-axis. Okay, this is the y-axis. Just I'm writing a rough figure. Okay, don't be get confused. Just I'm writing a rough figure. This is 1, this is 2, it goes on 3. Yeah, actually what we want the point 5. So somewhere there it exists. So minus 1 comma 1, minus 1 comma minus 1 means this point. So 1 comma 5 means somewhere else. This is just a rough figure. I will join these 2 points. So after joining this, see, I am joining these 2 points. Sorry. See, while drawing in exams, no, you please use the straight line. Sorry, use the scale to draw to join these 2 points. Just I'm writing a rough figure, so I I'm not getting the straight line here. Okay, so now I think somewhat it is looking like a straight line. So from this point, draw a perpendicular to the point 1. I'm drawing one perpendicular from this point, and from minus 1 also draw one perpendicular. What actually, which area we should find out here? This area. Okay, so this area we should find. The area enclosed by by the line y is equal to 3x plus 2, as well as the area enclosed by the points, ordinates they have given. Okay, so this area actually we should find out. So to find out this area, observe that the first point where it is lying on x-axis, the first point is lying on, see, this point is, I will mark this point as a, and this point as b, and this point as c. Okay, so the coordinates of this a is 1 minus 1 comma 0, and this is 1 comma 0, as it is lying on x-axis. Okay, we don't know the coordinates of the point b, we have to find out. Since the point is lying on x-axis, obviously y coordinate is 0. Apply this in the given curve. Well, what is the curve? Y is equal to 3x plus 2. When y is equal to 0, 3x plus 2, x is equals to what? Minus 2 by 3. See, so we got this point as minus 2 by 3 comma 0. See, from here to here and from there to 1. So now I will write down the given line equation, given y is equal to 3x plus 2. And also another one thing, the line cuts the x-axis. The line cuts the x-axis at minus 2 by 3 in, that means in between minus 1 comma 1. Okay, so now required area will be, required area is equals to integral from minus 1 to minus 2 by 3. See there, we should consider the modulus function, because even if you get the negative value, since we are finding the area, if you get the negative value, we should consider only the positive. So that's why we should write the modulus of that function. Minus 2 by 3 to 1, 3x plus 2, because this is minus 2 by 3 to 1 means it is above the x-axis. That means, isn't it? So I don't take here the modulus function. Only for the first term, I will consider the modulus function. So let me find out their integral. That means after integrating, what it becomes, 3x square by 2 plus 2, limit from minus 1 to minus 2 by 3, plus 3x square by 2 plus 2x, sorry, integration of 2 is 2x, limit from minus 2 by 3 to 1. Let me apply the upper limit now. See, actually it is a modulus function. You please try, keep the modulus as it is. Okay, don't forget to write the modulus. Modulus of, see, apply the upper limit, 3 by 2 into minus 2 by 3 the whole square plus 2 into minus 2 by 3. I applied the upper limit. Okay, so now I will apply the lower limit. Minus, put a negative symbol and apply the lower limit. 3 into minus 1 whole square by 2 plus 2 into minus 1 plus, so I applied the lower limit. Okay, now I am applying the upper limit, 3 by 2 into 1 square plus 2 into 1. Now I apply the lower limit, put a negative symbol, apply the lower limit. 3 by 2 into minus 2 by 3 the whole square plus 2 into minus 2 by 3. Okay. So let me simplify this further. So this is from here to here, it is a modulus. Okay. Modulus means even if you are getting any negative value, you must consider the positive value. So what it becomes actually 2 square is 4. 3 by 2 into 4 by 9 minus 4 by 3 minus it is 3 by 2 minus into minus plus 2 plus 3 by 2 plus 2 minus 3 by 2 into my 4 by 9 plus 4 by 3. Now let me simplify further. 2 ones are 2 twos are 3 ones are 3 threes are. After further simplification, modulus of 2 by 3 minus 4 by 3 minus 3 by 2 plus 2 plus 3 by 2 plus 2 minus 2 ones are 2 twos are 3 ones are 3 threes are minus 2 by 3 plus 4 by 3. Okay. So by taking the LCM, 6 is the LCM. So after finding this, what we will get? 6. After taking 6 has the LCM. 2, that is 3 it becomes, sorry, 6. 3 ones are 3 twos are 4 it becomes minus 8 minus 9 plus 12 plus even here 6 is the LCM. What we will get? 9 plus 12 minus 4 plus 8. See, be careful. Bracket is different, modulus is different. So let me simplify this further. 12 plus 4, it is 16. So 16 minus 8 minus 9, it is minus 17 by 6 plus this is 6 is the LCM. 12 plus 9, it is 21. 21 plus 8, it is 29. 29 minus 4. So it is 1 by 6. Because it is modulus, we must consider only the positive value. 1 by 6, 25 by 6, it is 26 by 6. So if you divide, it becomes 13 by 3. 13 by 3 square units. So this is what actually the required answer for the given question. See, writing the figure, you will get obviously 1 mark. Finding, that means finding the points and all, till here you will get 1 mark. Writing the required area properly, 1 mark. Integrating, 1 mark. And getting the final answer as 13 by 3, 1 mark totally. Even this is also a 5 marks question. Okay, I think you have understood this question. If you have any doubts in these for all the questions, you please put in the comment box. Please don't forget to subscribe my channel, like my channel. Okay, share my channel. Thank you.